All right, let's dive into something pretty incredible in the world of AI. It's called CarFlow, and really, it's a simple, super elegant shortcut that's completely changing how AI generates images, making the whole thing smarter, faster, and way more efficient.
You know, we've all seen the magic, right? You type in a few words, and bam, this powerful AI model spits out a beautiful, complex image basically from nothing. It feels like it's effortless. But under the hood, these models are kind of carrying this secret, inefficient weight. They're being forced to do two very different jobs at the exact same time, and honestly, it's holding them back.
And this just breaks down that two-job problem perfectly. So on the left, you see what a standard AI has to do. First, it has to travel this massive distance from a totally generic starting point. And then, along that long journey, it has to figure out what a cat even is. But look at CarFlow on the right. It basically just eliminates that first job. The journey becomes incredibly short, which lets the AI focus on what it's actually good at, creating the image.
Okay, so to really get why this is such a breakthrough, we first need to understand the old way of doing things. Let's take a look at the long, kind of scenic route that most of these image generation models are forced to take.
Here's a great way to think about it. Imagine you have a GPS for the entire country, but this GPS has this one really weird rule. Every single trip, doesn't matter if you're going to a coffee shop down the street or a beach across the country, every trip has to start from a single point, let's say in the middle of Kansas. It's this universal one-size-fits-all starting line.
Well, this is exactly what standard AI models do. They start from what's called standard noise. That's our fixed point in Kansas. So to create a picture of a cat, they have to learn the entire super complex path from that generic noise all the way to Cat City. Then if you ask for a dog, it has to learn another totally separate long path to Dog Town. It's just incredibly inefficient. So much of the AI's work is just spent on this long-distance travel.
And this, right here, is where CarFlow comes in. The researchers looked at this problem and proposed a brilliantly simple solution. What if we just move the starting line?
So let's go back to our GPS analogy. Instead of starting you in Kansas for your trip to Seattle, what if it could instantly teleport you to, say, the border of Washington State? All of a sudden, your journey is like 95% shorter. You're already in the right neighborhood. All you have to do is the final detailed navigation of the coffee shop.
And that is exactly what CarFlow does. It gives the AI what's called a condition-aware starting point. So for a cat prompt, it starts the AI in a place that's already vaguely cat-like. For a dog prompt, it starts it in a dog-like region. By aligning the start and end points, the whole journey, the path the model has to learn, becomes dramatically shorter. The AI is finally freed from that burden of long-distance travel.
Okay, but this introduces a fascinating new problem. If the AI is so good at moving the starting point, what's to stop it from just cheating? This is where the real genius of CarFlow really comes into play. I mean, it's the logical question, right? If you can teleport to the right state, why not just skip the driving altogether and teleport directly to the final image? Why not just give the AI total freedom to find the absolute ultimate shortcut?
Well, because, as the researchers themselves point out in their paper, that freedom is actually a trap. Giving the AI unrestricted power to move the start and end points leads to something they call a critical failure mode. Basically, the model learns a shortcut that's so effective, it breaks everything. This failure is called mode collapse. And it's pretty much what happens when the AI gets lazy. It discovers that the easiest way to solve the problem is to just produce one single generic image, or sometimes just meaningless noise, for every single prompt you give it. It collapses all the possible outputs into one useless mode. The shortcut becomes the only destination. And this can happen in a couple of main ways. As that first row shows, the AI might just learn to make the start and end points the same exact value every time. The result? Every image looks identical. Useless. Or, as you see in the second row, it might learn to just zoom out infinitely far, losing all the detail until you just get static. In both cases, the AI finds a zero-cost solution that produces zero-value results.
So the big question is, how do you get the benefit of a shorter path without falling into that mode collapse trap? CarFlow's solution is just brilliantly simple. It's a shift-only rule. It lets the AI move or translate the starting point, teleporting it to the right state, but it is strictly forbidden from changing its size or its shape. This simple little constraint is just enough to prevent all those lazy shortcuts while keeping all the good stuff.
Okay, This all sounds great in theory, but does this clever shift-only shortcut actually work in practice? Well, let me tell you, the results are pretty stunning.
Let's just start with the headline number. On the industry standard ImageNet benchmark, Careflow reduced what's called the FID score. That's a key measure of image quality where lower is better by nearly 19%. In a field where improvements are often tiny fractions of a percent, that is a massive leap in quality.
And this bar chart shows you exactly what that looks like. The baseline model, which is already state-of-the-art, scores a 2.07. But by simply adding CarFlow on top, that score drops all the way to 1.68. It's just a clear, significant improvement in how good the images look.
But here's the real kicker. This chart shows that this massive improvement was achieved by adding less than 0.6% of new parameters to the model. CarFlow is just that tiny little blue slice. It's an almost negligible cost for a nearly 20% boost in performance. I mean, that is the definition of an elegant, efficient solution.
So the takeaway here is super simple and really powerful. By just giving the AI a smarter starting point, CarFlow helps it train faster and produce much higher quality images, all without bogging it down with any extra complexity. It's a win-win-win. So let's zoom out for a second and look at the bigger picture. Because this isn't just about making prettier images. The core idea behind CarFlow, this idea of aligning a problem's start and end points, it has huge implications for the future of AI development. What this research really teaches us is first, that forcing an AI to shoulder that dual burden is a major bottleneck. Second, that simply aligning the start and end of a problem can make it dramatically easier to solve. Third, and this is so important, that simple rules like shift only can be the key to preventing these AI models from failing in really catastrophic ways. And finally, that finding these clever, efficient shortcuts, that's how we're going to unlock the next wave of AI innovation. It really makes you wonder, doesn't it? If an idea as simple as moving the starting line can deliver these kinds of results, it just proves there are still these fundamental breakthroughs out there just waiting to be discovered. The question is, what's the next elegant shortcut that's going to change everything all over again?